Unit 4, and we're doing part 2 of 4.2, and last time we looked at central location. Now we're going to look at spread. So we're going to look at how far the data has been spread apart. Say for instance when you wrote 3 tests and you found your average for the 3 tests was 10. Then you don't know, were my marks 10, 10, 10? Were they 5, 10, 15, etc. You've got the average, just tells you what was more or less the middle value, but it doesn't tell you if you got mostly close to 10s or if your data was very far spread apart. So measures of spread does help you to look at that. We're going to do this in terms of an example. So I'm going to say test scores of 9 students. I'm going to give you, and the test was out of 50. So this is the data I'm going to use the whole time. These are the different marks that the 9 students got. So I want to give a bit of space there. One measure of spread is the range, which is simply your maximum minus your minimum. In this case, 49 minus 0. So we know that the scores, the test scores are spread over 49 marks. But we still don't know too much about them. We don't know if they were evenly spread across the 49 or how they are spread. So we prefer to break it up into quarters. So if we break it up into quarters, here's what we're going to do. We don't call them quarters, we call them quartiles. And now be careful that you don't get this wrong. The first quartile, this rule here is where to find it, not what its value is. And the n is the number of students, the number of data you got, in this case 9. So a quarter of 9 plus 1, a quarter of 10 is 2.5. Q1 is your 2.5th observation. That's not the value of it. What you go is you go to number 1, number 2, and then in the middle, between 2 and 3, you get your Q1. And because it's in the middle, you take their average. So it is 8, and it is called the lower quartile. So this rule, remember here, is not the value, it's where to find it. Q2 is your median. But your median is literally just the same rule, but a half of n plus 1, which is a half of 10. So it's the fifth observation. It's not 5. It's the fifth observation. So your fifth observation is 25. That is your Q2. Q3, your upper quartile, is then 3/4 times n plus 1. So 3/4 of 10 is the 7.5th observation. Its actual value is go between the 7th and the 8th and find their average, which comes to 35, and it's called your upper quartile. Now this tells us such a lot. We've now broken it up into quarters. So what we're saying is that, for instance, let's first do the interquartile range. Interquartile range is your upper quartile minus your lower quartile, the actual values. So it is your 35 minus 8, 27. That tells you that the middle half of your marks, middle 50% of your scores, was spread over 27 marks. Or you could say the middle 50% of your scores are between the values of 8 and 35. So by dividing it into quartiles, you can also say now this is your top 25% of your scores are above 35, because remember your Q2 was 35. Your top 25% of your marks are above 35. Your top half of your marks are above 25. Because it's in quarters, you can look at the top half, the middle half, the lower half. Your lowest 25% of your marks are below 8. Don't look at the 1, look at your Q1, are below 8. So by dividing it into quarters, you've got a good idea of half of my marks lie where, the upper half lie where, the middle half lie where, etc. It gives you a much better explanation of how your marks are spread. Now, all of this we're going to put together in what we call a 5-point summary. A 5-point summary, I'm going to write them next to each other because of our shortage of space. Your minimum value is your first one. Your Q1 is your second value. Your median, or Q2, is value 3. Upper quartile. And your fifth value is your maximum. Now what we can do is we can do another kind of graph with this info. And we call this a box and whisker plot. Using your 5-point summary, you can draw a box and whisker plot. And again, I cannot emphasize enough that it has to be drawn to scale. So look at your values going from 0 to 49. Get yourself a good scale. Maybe let every value be 2 millimeters. Whatever, you can choose your scale, but then measure exactly using a ruler. This is my 0. This is my 49. So if I said every one is 2 millimeters, I would put 49 at 98 millimeters. Then I would mark off my 8, which would then be at 16 millimeters. You've got to choose. My 25 and my 35. And I can already see mine is not good enough to scale. Now, this is just your ruler. You just mark off your 5 points. Now, above it, not to touch it, you put down lines. And then the middle 3, you're going to join in a box. And the outer 2 are your whiskers. Okay. I did actually draw this to scale, and I know this between 35 and 49 wasn't really that long. Because you've got to now be able to see, wow, 25% of my marks lie there. So because it's a long one, it was spread over a big number of marks from 8 up to 25. But this is also 25% of my marks. So because it's shorter, this third quarter of my marks were quite close together. There were a quarter of my marks were between 25 and 35. So it gives you a very good idea, a very good picture of how your marks are spread. If it is a short distance like this one, then they are close together because it's still a quarter of all your observations lie there. If it's a long distance, then they are spread far apart.